Good day, everyone. This is Professor Friday from coming at you one more time. Today, indeterminate forms and using L'Hopital's rule. L'Hopital's rule can be used anytime we're dealing with an indeterminate quotient, and that's what we're going to take a look at today. For our first problem, we have the limit as x approaches 1 of x raised to the a power minus 1 over x to the b power minus 1. Now, in this problem, we're going to assume that a and b are real numbers. A and b are real numbers. Now, anytime I evaluate a limit, the first thing that I do is I immediately try the direct substitution property, which is a statement of continuity that says, let's plug in x equals 1 and see what happens. So this is the direct substitution property, which states plug in x equals 1, see what happens. So my numerator becomes 1 to the a minus 1. Denominator becomes 1 to the b minus 1. As long as a and b are real numbers, not infinite, then each of these will be equal to 1. So we have 1 minus 1 over 1 minus 1, which reduces down to 0 over 0. Anytime we have a limit that takes the form 0 over 0 or infinity over infinity, it's what we call an indeterminate quotient. And this is the perfect time for us to apply L'Hopital's rule. So I'm going to recopy down my limit. Limit as x approaches 1 of x to the a minus 1 over x to the b minus 1. We know that this takes the form 0 over 0, which is what we called an indeterminate form. So we can apply L'Hopital's rule. Anytime I apply L'Hopital's rule, I like to write down L apostrophe H apostrophe S for L'Hopital's. This would be equal to the limit as x approaches 1 of the derivative with respect to x of the numerator over the derivative with respect to x of the denominator. Anytime we have an indeterminate quotient, we can apply L'Hopital's rule. In a couple more examples that I post, we'll talk about other indeterminate forms like the indeterminate product, difference, or power. Evaluating these derivatives, be sure that each step you go through, you're still copying down that this is the limit as x approaches 1. If we forget to write the limit, it changes the value of the problem. Taking the derivative of the top, according to the power rule, derivative of x to the a is going to be a times x to the a minus 1 minus 0. Denominator is going to look similar. Oh, excuse me, that should be b minus 1. So we get a times x to the a minus 1 over b times x to the b minus 1. Now we're going to try direct substitution property one more time, which says let's plug in x equals a, see what happens. We get a times 1 to the a minus 1 over b times 1 to the b minus 1. Both of those powers of 1 are finite, which means that's a times 1 up top, b times 1 on the bottom. Our final answer for this problem is going to be a over b. Now let's look ahead. In this problem, we're going to be making multiple uses of L'Hopital's rule. We have the limit as x approaches 0 of the sine of x minus x all over x cubed. Over on the right-hand side, this is where I'm going to be using the direct substitution property. So if we try the direct substitution property, we're going to get sine of 0 minus 0 all over 0 cubed. Sine of 0 is 0, minus 0 is 0. 0 cubed is 0. Put it all together, that's a whole lot of 0. So we can apply L'Hopital's rule. Because we're going to be applying it multiple times, I'm going to simply say, hey, we're going to take the derivative of this numerator instead of writing down our notation with the d and the dx's. So, hey, we're going to take the derivative of this numerator. Derivative of sine of x is cosine of x. Derivative of minus x would be minus 1. In the denominator, we have an x cubed. Derivative of that is going to be 3x squared. If I try direct substitution property again, I'm going to get the cosine of 0 minus 1 over 3 times 0 squared. Cosine of 0 is 1, minus 1 is 0, and in the denominator, anything times 0 is 0, except for infinity, but we'll see that in the next example. Now what this means for me is that I can apply L'Hopital's rule again. So I will take the derivative of my numerator. Derivative of cosine of x is negative sine of x. Derivative of minus 1 is 0. And the derivative of 3x squared is 6x. So now I'm going to try direct substitution property one more time. I'll get negative sine of 0 over 6 times 0. Sine of 0 up top is 0. Well, negative 0, but you know what I mean. 6 times 0 in the denominator is 0. Looks like we have 0 over 0 again. So we get to apply L'Hopital's rule another time. So we'll take the derivative of the top. Derivative of negative sine is equal to negative cosine of x. And the derivative of 6x in the denominator would be 6. If we try direct substitution property with that one more time, that'd be negative cosine of 0 over 6. That is not indeterminate. It is unindeterminate. Why don't we go with not indeterminate? Actually, I guess we could just go with determinate, because we can determine this answer. That's negative 1/6. So, now you can go home and tell your parents, when your parents ask, what'd you do today? You can say, I divided by 0 and I got negative 1/6. Or, I divided by 0 and I got A over B. You're as powerful as Chuck Norris now. You can divide by 0. Well, thanks for viewing, and I'll post a couple more L'Hopital's rules sometime in the next couple days. Thank you for watching.